In this video, we're going to talk about some rules that are associated with the term significant figures. And if you recall, a significant figure is referencing digits that were measured. So when you take a measurement, such as on a balance or reading a graduated cylinder or any other types of measurements that you can take, there's a certain level of precision associated with that, which gives us this number of significant figures. So we never want to overstate the accuracy of our answers. So that's why we are always concerned with the correct amount of significant figures. So some rules noted here are that all non-zero digits are significant. So if I had 1,435 grams, all of those digits would be significant. So I would have four sig figs, we could say. In this next rule, we're told that zeros between significant figures are themselves considered significant. So if I have, for example, 1,005 grams, that also would have four sig figs, because both the 1 and the 5, the non-zero digits, and the zeros between, these are all significant. Then we're told in this third rule here that if we have leading zeros, or zeros at the beginning of a number, such as 0.0002 grams, for example, this would only have one significant figure, one sig fig, and all of those zeros will be non-significant figures. This last rule here tells us that zeros at the end of a number are significant if a decimal point is written, as opposed to just being a space holder. So if I have 50 here without a decimal place, that's only one sig fig, so one sig fig. Let's say I have 50 decimal place, that would be 2. And then say I have 50 decimal place 0, 0. All of these zeros would be significant. So this would be 4 sig figs here. So in sample exercise 5, we're asked to determine how many significant figures each of these quantities have. We're assuming that these are measured quantities, not something that you can count. So let's take a look here. In this first example, we have 4.003. So we'll follow our rules above, and we know that these are considered significant figures. These two zeros, they're sandwiched between two non-zero digits. So we have a total of 4 significant figures here. In this next example, we're going to learn the significance of this value here. This is Avogadro's number. And notice we have a decimal place, so that 0 there is definitely going to be significant after the 6. And actually all four of these are going to be significant figures once again. Now, if you can't tell, there is no decimal place after the 5,000 there. So this last value only has one significant figure. So we're going to look at how determining the amount of significant figures that we're starting with before we calculate can determine the amount of significant figures that we end up with in our final answer. So when addition or subtraction, so we have addition or subtraction being performed, the answers are rounded to the least significant decimal place. So say I have 50.01 and I don't know, 50.1. So this is my least significant decimal place. So I will add these numbers up. I get 100.11, but I'm only going to have significance to this point here. So my final answer will be rounded to just 100.1. Again, this is based on the least significant decimal place when we add or subtract. We can see next here when multiplication or division. So now we have multiplication or division. We're going to just look at the least number of significant figures. So let's say we have, I don't know, 135 times 10 here, for example. So we can see that there's only 2 sig figs here and 3 over here. So my final answer, I'm gonna multiply this and I get 4 digits, but I'm going to end up with only 2 sig figs. So that would be right here. So if I wanted to round my answer to the correct number of sig figs, whatever this unit may be, I'm going to have 1,400. So least amount of significant figures with both multiplication and division. So remember the difference between the number of sig figs in your starting values and how we end up with the number that we report after our calculation. We should also note that exact numbers, exact values have an infinite amount of significant figures. So if there are 12 eggs in a dozen, it's going to be 12.000 to infinity. For example, conversion factors, we can also consider having an infinite amount of sig figs since those are exact values. So there's 1,000.00 grams. Oh, that's supposed to be a G there. Grams in 1 kilogram. But those decimal places we know will be to infinity, also with the 1.000 kilograms. I also touched upon some rounding. So if we have a digit that is less than 5 next to the last digit, we keep the number the same, so it's left unchanged. If we have a 5 next to it, we would round up. So, so that's called right here. The preceding number would then be increased by 1. So you saw that I did that when I rounded my 3 up to a 4. So when we have multiple steps, so more than one step, we always keep at least one non-significant figure until the end, and then we'll round at the very end. I tend to keep all my digits in my calculator until I'm done, and then I'll round after my final step is performed. So we'll continue with sample exercise 6 in the next video.